All right, so here we are in the first toolkit entry for Chapter 10, and this one's entitled More Circle Vocabulary. And you're going to go ahead and put some definitions in your toolkit and also some diagrams as well. So here's our first diagram. We've got a circle. We've got the points A and B and D that are along the circle, and then we have the center here marked with a C. And we have two radii drawn out here from C there. So the first major idea here for circle vocabulary is the idea of what we call an arc. And what an arc is this. If you were to look out here on the circle, we have basically, if we went from A to B here, this could be what we call a minor arc here because it's only part of the entire circle here. Now we call it a minor arc because it's going to be the smaller one of the two. And how we symbolize that is we write A, B with the arc symbol above it here. We also have another arc, and this arc starts at A, wraps all the way around here, and goes all the way out to B. So in this case here, we can't call it arc AB because that's where it ends because we've already done that for the smaller one here. So what we do for the major arc, the larger one, is we call it A and it goes through D out to B, and then we put our arc symbol right there. Another idea, we've talked about this before, is the idea of what's called a central angle. Our central angle in this case is right here, okay? And basically the idea is this: the vertex is at the center of the circle, hence central angle, center, central. And so in this case here, we could identify that as angle ACB. Make sure this gets in your toolkit, pictures included too. Next up, we have the idea of what's called a chord. And a chord is, as it says here, it's a line segment where both endpoints are on the circle. So you can see F and G, the endpoints are actually on the circle itself, and there's our line segment. So this is the chord right here, and we would call this chord FG with the line segment symbol above it that we've used in the past. Finally, in terms of terminology here, we have the idea of what we call an inscribed angle. The inscribed angle, I'm going to put the angle mark right here. The vertex, instead of being at the center of the circle, the vertex is actually on the circle itself. The vertex is right here, and then it continues out. Its endpoint is where it intersects the circle, and the other endpoint's over here. So this is what we call an inscribed angle. Inscribed angle right here. So it would be, in this case, your angle LMN, or of course you could reverse that as well, and that's fine too. So make sure all this gets in your toolkit, the definition, the diagrams, etc., here. Alrighty, now we're going to move on to actually using some example and some numbers here so you can see how it works even further here. So what I've done is I've gone ahead and made this new circle here. The points are T, R, and P. I'm sorry, T, R, and Q. P is the center. We have a central angle here. It's measured at 72 degrees. That's an angle right there. And we're going to answer some questions. So first of all, the measure of the minor arc. Well, the minor arc, once again, is this part right here. So we could say measurement, which is a little m here, of arc RT equals, and the question is, well, how much is it? It's the exact same as what the central angle is. So it's going to be 72 degrees. We can write equals 72 degrees. We're also going to measure the major arc here, and the major arc starts at R, goes through Q, wraps all the way around the circle here, and there it is at T. So we could say the measurement of arc, and it would be RQT, equals, and the question is, well, how much would it be? Well, both arcs make the entire circle here, and an entire circle is 360 degrees. So what we would do is we take 360 and subtract the 72 minor arc, and how much is that? Well, it's 288 degrees. So that would be the measurement of our major arc here in this case. We also have a central angle, and that angle is measurement. The angle is RPT, and it's 72 degrees. And we know that because we can read right here. But once again, notice the minor arc and the central angle have the exact same measurement here. Okay. Finally, we are going to talk about minor arc length, and we've already done arc length before, and the only reason why we're saying minor is we're looking at the smaller of the two arcs. We could also look at the major, but in this case we're only going to look at the minor. So when we're talking about arc length, length is a little bit different. We're not talking about degrees, we're talking about how long is it. And all we know is our radius of our circle is 5 centimeters. So this is 5 centimeters right here. So what we want to do is we want to find the entire circumference. Well, the entire circumference would be 2 times pi times 5. And then what we do is we multiply by what part of the circle we want. We only want 72 degrees out of 360. So you grab your calculator, take 72, divide by 360, multiply by 2, and pi, and 5, and then when you do that, you should get, not equal, but you should get approximately, if you round off to two places, 6.28. And of course, remember your units, so it's 6.28 centimeters. So once again, just to point out, you can have your arc length, that would be actual units here, so it'd be centimeters, but you can also talk about the measurement of that minor arc in degrees. So it's either 72 degrees as a measurement or as a length, 6.28 centimeters. There's actually two ways to measure that. So that's our first toolkit entry for Chapter 10.